Okay, so I think Okay, welcome again. So nobody else has joined. I should start with you. Uh, Hope my screen is visible, right? And I hope I am audible also. So let's start. So welcome. Good evening. My name is Shutol Khotokhan. I am a TA of this NPTEL course code C31, C39. I am a research scholar of IIT Bombay, and this is your week 9 session. Previously, it was occurring on Tuesday, but later I shifted it to Sunday because of some work. The course title is Water and Wastewater Treatment, instructed by Dr. Bhanu Prakash Bhelanki, who is an environmental engineer from the Civil Engineering Department of IIT Roorkee. So we have till now finished 8 weeks. Now it is the 9th week, March 24th. And after one another week, the March session will be completed and only 2 weeks will be left thereafter in the month of April. So our first question of today is as follows. So consider the below statements which are related to rapid gravity filter backwash and tapered flocculator, and you have to choose the correct ones. Statement 1 is backwash velocity must be lower than the settling velocity of the smallest media particle. Statement 2 is total volume of the media bed as well as the volume of media solids increases during the backwashing. And statement 3 is tapered flocculation is more efficient when compared to the conventional processes of flocculation as it promotes aggregation of small particles into larger aggregates to enhance their removal by gravitational force. So you have to tell within these statements which are wrong and which are correct ones. Okay, you can type your answer in the chat box. Yes, Archana. So the first two statements are based on the rapid gravity filters backwash. The third statement is related to the flocculator. Any guesses? Or if you have identified any one or two among these three statements, whether they are correct or not, then you can also type your answer. I think I should tell the answers, right? Okay, so the statement 1 and statement 3 are correct answers, and the statement 2 is wrong statement. Why? So first, the statement 1 says backwards velocity must be lower than the settling velocity of the smallest media particle. If in a filtered media the backwards velocity is greater than the settling velocity, then what happens? See, the filtered media is basically filled with sands or some other particles. They are basically the media particles. So if the backwards velocity is more than the settling velocity, then the media particles, those are inside the chamber, inside the filter chamber, they will basically go out with the backwash water in a reverse direction, right? Reverse direction. So that's why backwash velocity must always be lower than the settling velocity of the smallest media particle. Now what the statement 2 says, why it is wrong about the media, because it says total volume of the media bed as well as the volume of media solids increases during backwashing. So this total volume of course increases because while backwashing their porosity increases, but the volume of the individual media solids, that doesn't increase, because they are solids, their essential nature is they are not soluble in water, and also they don't absorb water, so they don't soil also, right? So that's why their individual volume doesn't increase, it remains the same. Only the volume, total volume increases, porosity increases, but the volume of the media solids remains the same. So that's why this statement as a whole is a wrong statement. And this is the right statement. Tapered flocculation is more efficient when compared to the conventional process of flocculation, as it promotes aggregation of small particles into larger aggregates to enhance their removal by gravitational forces. So what is tapered flocculation basically? This is a tapered flocculation where the flow happens tangentially. So Archana, are you also from IIT Bombay? I can see your
Sir, I'm
yes.
from Guru.
Okay, your voice is not very clear because when you rejoined, your names showed something like that. It's okay. So let's continue. You can also type because it was,
Basics from Ruby.
your voice is not very clear. I cannot. It's okay. Because when you joined in brackets, your name showed like that way. That's why I'm asking. Okay, no issues with that. So this is a very tapered calculation, and you can understand why the statement is correct from there. And this is something the depth filter and the surface filter, based on which a few couple of next MCQs will be there. So what is the depth filtration? This is very tapered calculation. Media filter, you can understand, it's a just like a sand filter or gravel filter, which are very conventional in nature. And this depth filtration and surface filtration, this is something like in case of depth filtration, the particles, there is a mixed kind of smaller ones and the larger ones, and the smaller ones, if you want to filter them out, they actually diffuses through the filter medium. But if there is a huge difference between the filtrate and that thing that must be retented from the solution or whatever, so there must be huge gap, and the porosity of that filter must be such that it should prevent the non-desired one from passing. So that's why in case of surface filter, the example is let's say membrane, as it prevents monovalent or bivalent ions to pass through, just like nanofiltration, reverse osmosis, etc. And in the case of surface filtration, there is no diffusion takes place. In the depth filtration, it actually separates out with the help of the diffusion. Okay, so Now the next question is between mechanisms and characteristics. You have to match the typical population mechanisms with their characteristic features. So the mechanisms are: number one is micro scale or perikinetic, number two macro scale or orthokinetic, number three differential settling, and their characteristics are caused when particles have differential settling velocities, B is caused by Brownian motions, and C caused by related motion of fluids. So these are the mechanisms, these are their causes. So you have to identify which mechanism has the which correct cause, that you have to identify. Please type your answer in the chat box. Okay, you are from Roorkee. Okay, IIT Roorkee. From which background you are? BTech or MTech or BSMS?
Sir, I have passed my MSc from Environment Science.
Oh, environmental science. Bachelor degree or masters?
Sir, postgraduate
Postgrad.
masters.
MA. Okay. You just type your answer in
2020.
the chat box from here. Environmental science means this course must be easier for you. You should be able to answer. No answer? Then I think I should explain, right? So there is no explanation basically. This is just a memory based question. So which one is explained by which one? That is the thing. Let's say. So let's say macro scale motions and micro scale motions, right? So I believe micro scale motions must be Brownian motions. Let's say, what is the answer? Yes, micro scale or perikinetic is caused by the Brownian motions. The macro scale or orthokinetic motion mechanism is caused by the relative motion of the fluid. Basically, it is the relative motion between different layers of the fluid. And the differential settling is caused when particles have different settling velocities. So this is just the definition. So the differential settling occurs. It is the actually the basic principle of the differential settling is caused by the difference in the settling velocities of different particles. So I think you should have answered this one because you just have to identify the Brownian motion. Then the other one was obvious, right? Yeah. Oh, you have answered BSc. Yeah, BCA it should be. Wait, no. Okay, so B you have identified. So settling velocity is also it is based on the differential settling velocity. The only thing is left is 2 is C. So there is no confusion that 3 is A, right? So only the confusion was 2, but it was only left. So I think it should have been said correctly. So the thing is that have you heard about what is called ensemble in thermodynamics? So in thermodynamics has different parts. So one was basic part which we studied in undergrad level, but in the postgrad level, the thermodynamics there was statistical mechanics. So in the statistical mechanics, there are different kinds of ensembles. Ensembles is not a single atom or single molecule or a very few atoms or molecule systems. These are very large, the set of very large amount of molecules. So it is basically a macro scale thing, right? So these ensembles, there are different softwares to study this group of molecules or group of atoms. There are different kinds of theories, density functional theories, etc. And there are different kinds of simulations like molecular dynamics simulations, which do the macro scale thing. So actually, they actually studies in if this thermodynamics, this statistical thermodynamics is combined with the fluid mechanics, then they can study the motion of fluid in different layers, layer by layer. So that's why in this way, the macro scale is caused by the relative motion of the fluid. Okay, so this is the answer, correct answer. Okay, so let's move on to our next MSQ. This is a multi-select question. So more than one option may or may not be correct. Which of the following is or are the mechanisms of depth filtration? A হচ্ছে interception, B sedimentation, C diffusion, and D none of the above. Type the correct answer in the chat box. So I think I should wait in each question, right, for you to think. Maybe you are answering, but I am starting the explanation. So I think I would wait a bit for you to answer. Okay, you are saying interception and diffusion for depth filtration, right? Okay, let's see which was this the correct answer. So all of them, none of them is not the correct. So whatever you have said, it is also correct. And also sedimentation is also a mechanism of depth filtration. Okay. So whatever you have answered, that is correct. But if you are giving GATE exam, then you have to select all the correct answers. That's the thing. Okay, so now let's move on. So again an MSQ. Which of these statements are true for granular media filtration? So again, more than one option may or may not be correct. Option A is head loss decreases with increase in time of operation. Option B, filter ripening generally occurs within 24 hours. Option C, head loss increases with increase in time of operation. And option D is none of the above. So, which of these statements are true for granular media filtration? Let's say option A and C cannot together be correct, right? Because one is telling us head loss is increasing and another one is telling us decreasing. So either option A or option C will be correct, or none of them will be correct, right? So option A or maybe one of them must be correct, because as the time of operation increases, the there will be deposition within the filter media. As the deposition increases, pressure drop also increases, and that means whether the head loss increases or decreases, that you have to decide. There is always a relation between the pressure drop and the head loss. So only one option between A and C will be correct. And option B, whether it is correct, option D is obviously will not be correct. Whether option B will be correct or not, that you have to decide, is just memory based. So so either option A or C, and or option B, that you have to answer. For granular media filtration. So I believe I should answer. So option B is not correct in this case. Only option C is correct. You can see that as I told, if there is deposition, the pressure drop will increase, and pressure drop means what? Head loss. Pressure drop means head loss only. So if there is a pump, it is pumping the water through the filter media. Then as the time passes, the load in the pump will increase to maintain the same flow and all. So there will be, as there will be more pressure drop, there will be more back there will be more back pressure on the pump. So that's why your load of the pump increases. That means the head loss will increase with the time of operation. But ripening will not occur within a day. Ripening means what? Basically, sar gaya. There is so much deposits in the filter media, it has got ripened. It will not occur within 24 hours because before that the backwash, they will give the backwash. If there is no proper backwash, then only the filter ripening will occur after a week or so, not within a day. Generally, in industries, after the filter media is used, the granular media filtration is used as a very preliminary treatment. So maybe once in 3 days they are given backwash. So that's why it will not occur within within 1 day. Okay. So let's move on. Now this is a granular bed filter media. Okay. The inflow is coming as it was given in the last MCQ. The inflow is coming and the outflow is going from the top to bottom. It is taken from this website. So from top to bottom, there are basically the sand particles and then the gravels. Then there are the uh, these are basically broken bricks. So all of them basically separates very fine particles which are basically insoluble in nature. That means their diameter size is more than 10 to the power minus 5 meter or 10 to the power minus 3 centimeter. Okay, so those types of particles are separated by the with the help of this granular bed filter media. Now what happens that above the sand there will be a layer of the deposits. As in the earlier MCQ, it was told that the as the time increases, the deposits also gets increased, and as the deposit gets increased, there more effort will be needed to pass the water through the media. So that means the pressure drop or head loss also increases. Okay. So what is called as filter ripening? So if there is a there are disjoint deposits, then the filter is not ripened. But if a layer, continuous layer gets formed on the filter media, it is called as the smooth deck. So if there is a formation of smooth deck and proper backwash is not given, then the filter ripening occurs. Okay. So what is this smooth deck basically, which is the main cause for filter ripening? So it is basically a German word which is called as dart cover or dirty skin, sometimes also wrongly spelled as smudgedeck. It is a hypogel biological layer formed on the surface of a slow sand filter. Slow sand filter is an example of granular bed media filter. So here where the granular media bed is made of sand. Sand is granular in nature, okay, and acting as a filter. The hypogel means under earth. Hypo means under, G means earth, and it is a ancient Greek word. Okay, so this means underground basically. And smooth deck is a this biological layer that gets formed of deposits that gets formed on the sand. In case of slow sand filter, it is called as smooth deck, which is German. And this smooth deck is the layer that provides the effective purification in potable water treatment. Potable water means drinking water treatment. The underlying sand providing the support medium for this biological treatment layer. So whatever layer gets formed, and there is a cross of the filter type any, it's called as the smooth deck. The underground sand basically provides the support for smooth deck. Okay. In case of potable water, it provides your effective purification. So in some cases, the smooth deck also helps in your purification process. The example is your potable water treatment, drinking water treatment. Okay. So the composition of any particular smooth deck varies, but will typically consist of gelatinous biofilm matrix of bacteria, fungus, protozoa, and rotifera, and a range of aquatic insect larvae. But before this, up to this bacteria, fungi, protozoa, and rotifera level, then it is okay. But once the aquatic insect larva comes into this smooth deck layer, then it cannot be treated for potable water. Okay. So as a smooth deck ages, more algae tend to develop and larger aquatic organisms may be present, including some bryozoa, snails, and annelid worms. So once these annelid worms started form in the smooth deck layer, then it can be called as the filtered bed media is ripening, or the uh, filter as a whole is ripened. Okay, it is no more suitable for treatment, right? So hope it is clear. Next, some questions will be based on this smooth deck. So MSQ, multiple select question. Which one of the following statement is or are correct? This is based on smooth deck. So option A, smooth deck layer is not formed in slow sand filter. Option B, smooth deck layer increases the quality of filtration. Option C, smooth deck layer takes around 1 hour to get formed after being scraped while cleaning the filter. And option D, smooth deck layer is formed by the process of biological metabolism by microorganisms. So you have to choose the correct statements. If you have understood the smooth deck layer, what is it, then you should be able to answer. B, C, and D. Increase the quality of filtration to some extent, yes. Usually it takes around 1 hour to get formed after being scraped while cleaning the filter. Okay, this is what treating as correct. Smooth layer is formed by the process of biological metabolism by microorganisms. Okay. So the correct answers are option B and D. So B and D you have identified as correct. And slow sand filter, it is obviously forms this smooth layer. It is not, as it is not formed. But what happens within 1 hour? So as I told in the earlier MCQ before the smooth deck layer, it was stated that within a day, that is 24 hours time, a filter cannot the pressure drop and whatever, because of this smooth deck layer, it cannot happen within 1 day of time, right? So how it can be possible that within 1 hour it can happen? If within 1 day it cannot happen, then and also comes at the ripen stage after 1 week, if no backwash is given, then within 1 hour how can it get formed? So within 1 hour basically no biological layer, though in some particular, in some individual level it can get formed, but once it forms a layer, then actually it calls as the smooth deck. The term smooth deck is used, the German term. But within 1 hour, the formation of such layer is not possible. Eh, So within 1 day it is not possible, and so within 1 hour it obviously is not possible. So after 2-3 days it may start to form if no backwash is given. Okay. So after cleaning and scraping, so within 1 hour the layer cannot form. It takes more than that. Okay. So, so B and C is correct as you have correctly identified. So now let's move on to our next MCQ. Now it is a single option. Single option will be correct. So sanitation is considered as available when A, sufficient number of toilets are available, B, collection, transport, treatment and disposal and or reuse are ensured in a hygienic way, C, toilet facilities are easily accessible and free, and D, privacy is ensured, especially for women and girls. When the sanitation is considered available? That is the question. Okay, you are telling as option B. Let's see. The explanation is as follows. Only proper collection, transport, treatment and disposal and or reuse of water in hygienic way can ensure sanitation. This can prevent various health related problems by preventing occurrence of waterborne diseases. So whatever you have given, option B is the correct answer. Okay, right. So now next MCQ. That is single choice. Waterborne disease caused due to improper sanitation is option A typhoid, option B tuberculosis, option C hepatitis B, option D scurvy. Okay, we're telling option A. Let's see. So the explanation is the typhoid, option A, is caused by a bacterium called as Salmonella typhi and is spread through infected water. The option B, that is a tuberculosis, that is caused by Mycobacterium tuberculosis and is spread through airborne from person to person, while people with TB affect the lungs during cough, sneeze, spit, laugh or talk. Hepatitis B is caused by hepatitis B virus that spreads through blood, semen and or other body fluids. And scurvy is caused due to deficiency of vitamin C. So whatever you have given, the option B is the correct choice. A, option A. Typhoid is caused by the improper sanitation because it is water. Okay. So now next MCQ, single choice answer. Inhibitors to success for implementation of right to water and sanitation includes option A, awareness and lack of funding, unawareness and lack of funding. Option B, public reservation against water and sanitation rights. Option C, no interest by state parties. Option D, conflicts with commercial interest. Which one of the following can be an inhibitor to success for implementation of right to water and sanitation? Okay, we're telling option B, public reservation against water and sanitation rights. So the explanation is unawareness among common people can result into unhygienic living conditions. Lack of funding restricts states to plan a proper system for water distribution and collection and or disposal of used water. Thus, it is an inhibitor in success of right to water and sanitation. So, unawareness and lack of funding is basically your inhibitor for the implementation of right to water. Okay. Any objection you can say? Because basically public will generally not protest against water and sanitation rights because it is there. If it is fulfilled, they will be happy. If it is not fulfilled, then only they will be unhappy. They will never show reservation against their own rights. Right. The unawareness and lack of funding, basically, it is the inhibitor because people sometimes may not know whatever their right is. So if there is no right, then the agency they will be reluctant to implement the same. And if there is no, in the absence of funding, nothing can be done. So that's why option A is the correct inhibitor for the success to the implementation of right to water. Okay, water and sanitation. Now next MCQ. Which one of the following is correct entitlement under the right to water? Option A, minimum 150 liter per capita per day of water. Option B, free water. Option C, safe and acceptable quality of water. Option D is all of the above. Option C you are saying. I think it is correct option only. Let's see the explanation. So free water supply and or minimum 150 liter per capita per day cannot ensure quality of the supplied water. Only safe and acceptable quality water is correct entitlement under the right to water. So you have answered it correctly. Okay. Now next MCQ. Which one of the below criteria is vital for human right to sanitation but not for human right to water? Option A, affordability. Option B, safety. Option C, privacy. Option D, physical accessibility. Which one of the following criteria is vital for human right to sanitation but not for human right to water? ये sanitation से related है पर water से नहीं, right to water से नहीं. Okay, we're telling option B. Let's see the explanation. So both human right to water and human right to sanitation emphasize that water and sanitation services should be physically accessible, safe, and affordable. Further, sanitation services should also offer privacy, which is not a criteria for water services. Okay, so option C, that is the privacy, is the correct answer. It is related to human right to sanitation, but not for human right to water. Okay, so you can see the affordability both will happen, right? But safety, also sanitation, and uh, human right to water, physical accessibility, both are related. But in case of privacy, so only sanitation is something which is, I mean, the thing, the motion of privacy is related with that. But human right to water, you are just using the water, it can be in open. So privacy is not basically linked with that. Okay. So human right to water only there. Privacy is something which is related to the human right to sanitation, but not with the human right to water. You told safety, right? So safety is also something, both is required, because if you see the human right to water, the water that you will be using, um, be it for household purpose or be it for your drinking purposes, the water must be safe. So no pathogen, virus, or no harmful chemical must be present in the water. And also, if something is used for sanitation, so then also, excuse me, yeah, then also, if something is used for sanitation, then also the, let's say some chemical is used for sanitation, then also the chemical must be safe. And if the water used for sanitation, then also you want to have to take care that after washing or something, then the water becomes polluted. So that must be treated before throwing to the directly to the environment. Or let's say the water is directly applied on the human body for sanitation purpose or something, then also that water, there must not be anything in that water which affects, which the skin is affected by which badly. Okay, so safety is related to the both the aspects. Only the privacy is something which is related to only one aspect, the sanitation, but not related to the human right to water. Okay, so I hope it is clear. Now it is 8:01, so we will next. There are basically problems for solving. So MCQ actually ends here. So we will take a short bio break. Maybe we can join after 8 to 9 minutes. On 8:10 we will join. Rejoin in the same link. Okay. So we'll take a short break. Then we'll rejoin in the same link. Or you can also ask any question if you have any doubt regarding this or this session or any previous sessions. You have, if you have watched any recording, then you can ask questions about that also. Or you can also type in the chat box. Or you will join at 8:10 sharp. Okay. And we'll start solving problems in the next hour. Okay. হ্যাঁ বলো, আমি আবার কি বলবো? তুমি কল করেছো, কি হ্যাঁ হ্যাঁ করছো? আমি কিছু বলিনি, তুমি কি বলছো বলো? হ্যাঁ আমি পড়াচ্ছি তো, ওই 8টা, দুই বাজ থাকে না, 7টা থেকে 9টা অব্দি। এখন ব্রেক চলছে, মাঝখানে 5 মিনিটের ব্রেক দিয়েছি, শর্ট বায়ো ব্রেক, ওই সময় তোমাকে কল করছি, 8টা 10 থেকে আবার শুরু করবো। হুম। এইটা করাতেই কত চাপ, এমনি কাজ পড়ে আছে এখানকার। এই বোলেরো কালকে ড্রাইভার কি করে গেছে, চাবি দিয়ে চলে গেছে নাকি লিডারকে, সেই সবগুলো আপডেট করতে হবে। ওর মাঝখানে এইসবগুলো না করে ওর মাঝখানেই কথা বলছি তোমার সাথে। সে এখনো জয়েন করেনি, একটা স্টুডেন্ট আছে অর্চনা কুমারী, যে একজন এখন করছে, আবার আবার জয়েন করে পরে তখন আমি আবার ইয়ে করবো, সেকেন্ড হাফের পরে তখন আবার অনেকে আবার সেকেন্ড হাফে জয়েন করে 2-3 জন। ও জয়েন করবে তখন আবার শুরু করবো, অসুবিধা কিছু নেই, বলো না। হুম। কি হয়েছে? শরীর খারাপ নাকি? হুম। কি হয়েছে? কি এখন হবে? হুম। কালকে? আচ্ছা আচ্ছা। এখন তো এগিয়ে আসছে না, অনেকটা এগিয়ে আসছে। প্রথম সপ্তাহে তো থাকে, ফার্স্ট উইকে তো থাকে, তো এতটা এগিয়ে। হ্যাঁ, কি জানি। উম, যাই হোক, ঠিক আছে। হুম। হ্যাঁ। নাও, নাও। কি হয়নি? ঠিক আছে, আবার স্টুডেন্টে জয়েন করেছে, পরে কথা বলবো, ঠিক আছে। ওকে, সো ওয়েলকাম এগেন, we should resume. Sorry. Yeah, yeah. So okay, so this option was correct now. Hmm, yeah. So next problem, you have to calculate the percentage recovery for a RO unit, reverse osmosis unit, with the following data. So data is given as follows: feed water flow rate is 2300 meter cube per day, retention flow rate is 600 meter cube per day, TDS in the feed water is 800 milligram per liter, TDS in permeate is 80 milligram per liter. Yeah. So this is the data given only. Based on the data, you have to calculate the percentage recovery for a RO unit. So the RO unit or whatever is not important. Whatever unit it is, based on the data only, you can calculate the percentage recovery. Okay. For be it a RO unit or NF unit or UF unit or MF unit. Based on these data, you can calculate. Or maybe all the four data also may not be required. Maybe some of them are non-useful data, some of them are useful. So you can only use the useful ones and calculate the percentage recovery. Yeah. You can calculate and type your answer in the chat box. Very easy problem. If you know what the percentage recovery means what? If you understand what is reject and what is recovered, so then you should be able to answer. Okay, you're telling 73.91%. Okay, so let's see the calculations. I hope the uh, answer was around that only. So let's see. So the useful data given is feed water flow rate in meter cube per day is 2300 and retention flow rate meter cube per day is 600. So the TDS data, that is all the both the data that is given here is not necessary. These are non-useful data. Solution is, if feed water flow rate is this, retention flow rate is this, then the permeate flow rate in meter cube per day will be 2300 minus the retention flow rate 600 equals to 1700 meter cube per day. Okay. So the percentage recovery will be permeate flow rate, that is 1700 divided by the feed water flow rate. This is the fraction and percentage means into 100. So 1700 divided by 2300 into 100 equals to 73.913, approximately 74%. You have answered it correctly. So what is the case? Basically, your here the recovery is in terms of the water. Where the RO unit is installed, it is basically installed either in your home, where you are using it for in your let's say in your water filter for drinking purposes, right? Aquaguard or something, or you are using in industrial areas where you have to throw the water into the environment. Before throwing, you have to or you have to reuse the water. Before reusing, you have to eliminate all the salts from the RO. So there is one stream that will come from the RO or any type of membrane processes that will be very much concentrated in the pollutants or in the salts, whichever. So that stream is non-usable. But the usable thing is the water. So you are focusing on the water. So that means whatever permeate will be there, that will be your focus, that will be your recovered. So whatever feed water is there, you are recovering the permeate out of the feed water. So that's why, as the focus is on the permeate, that's why your recovery is permeate flow rate divided by feed water flow rate. Let's say it is a fruit juice industry. Okay, you are concentrating the fruit juice, then the recovery will be your retented divided by the feed water flow rate. But it is not so in this case. It is water flow rate, right? Not fruit juice. So that's why your focus is based on the permeate whenever you are calculating the recovery percentage, right? Okay. So now let's move on to our next problem. Consider a coagulation treatment plant having flow rate equals to 0.15 meter cube per second. Alarm dosing is 22 milligram per liter. Influent suspended solids concentration is 30 milligram per liter. Effluent suspended solids concentration is 15 milligram per liter. Stoichiometry equation of alarm is Al2SO4 whole 3 dot 14H2O, which gives 2AlOH whole 3 aluminum or hydroxide as solid precipitates, plus 6 hydrogen plus ion plus 3SO4 2 minus ion, basically this H2SO4 plus 8H2. Okay, so once you add the alum in the water in a coagulation treatment plant within its aqueous solution, it actually gets splitted into these ions. So now you have to, based on the above data, you have to calculate the amount of total dry sludge solids produced per day in kg per day. Hint is atomic mass of aluminum is 27, sulfur is 32, hydrogen is 1 and oxygen is 16. These are grams per mole or kilograms per kilomole. Okay. So I'll wait for 5 to 7 minutes for you to calculate the amount of total dry sludge solids produced per day in kg per day. Dry solid means what? Dry sludge solid means the aluminum hydroxide. If it was told that total wet sludge solids, then you have to consider the water, 8 moles of water plus 2 moles of AlOH whole 3. Both you have to consider, but here they are only telling the AlOH whole 3. So you have to consider the dry part of this. That means only the aluminum hydroxide. Okay. Per day basis you have to calculate. So flow rate is given meter cube per second. This thing either you can at the beginning you can convert it into per day basis, then you can run the whole calculation, or you may run the whole calculation and at the last whatever dice rates will be at per second level, then you can convert it to per day level. In any way you can proceed, it's up to you. So I'll wait for 7 minutes, let's say, then I'll give you the solution. This is a big problem, so I'll give you some time. I'll proceed with the solution after a couple of minutes. I'm calculating it, right? Okay, we have calculated 114.048. Okay. So let's proceed with the solution then. Hmm. Okay. So now the solution, right? Huh. So the flow rate given, that is 0.15 meter cube per second. Here at the beginning, we have followed the strategy that we are converting into per day level. So if we convert it to per day level, that means into 3600, that means per hour into 24. So into 3600 into 24, 0.15 becomes 12960 meter cube per day. And alarm dosage added is given in the question as 20 milligram per liter. It is given, right? Yeah, alarm dosing is given. Okay. So now from this stoichiometry, we can see that 1 mole of alum produces 2 moles of solid aluminum hydroxide. So 1 mole of alum is producing 2 moles of aluminum hydroxide solid, dry solid sludge. That we can see. So the molecular mass of alum is 594 gram. How did we came in this 594? It is 27 plus oxygen 16 plus 1 is 17 into 3. So 27 plus 17 into 3 within bracket whole into 2. So in this way 2AlOH whole 3 that will come. That will be the solid of the that will be the mass of the dry solids produced from the alum. So the alum's molecular weight, that is 594, that came like this way. So H2O 18 into 14, whatever that is, plus 2 into 27, that is 54, plus 32 plus 4 into 16, that is 64. So 32 plus 64 whole into 3 plus 54. This one plus 14 into 18. So I hope this value will come as 594. If you have calculated correctly, you will also get that. Now, the molecular weight of AlOH whole 3, as I told earlier, it will be 27 plus 17 into 3 equals to 78 gram. Now, 594 gram of alum produces 2 into 78 equals to 156 grams of aluminum hydroxide precipitates as solid sludge. Therefore, 1 gram of alum produces 156 gram divided by 594 gram equals to into 1 gram equals to 0.263 grams of aluminum hydroxide solid sludge precipitates. Hence, 22 milligram per liter of alum will produce 22 into 0.263 equals to 5.778 milligram per liter of solid sludge precipitate. Why we are considering this 22 milligram per liter? Because this is the alarm dosage that was given in our question, and we have to calculate the solid sludge precipitate based on the alarm dosage given in the question only. So that's why we are multiplying this 0.263 with this 22. This factor came by this way. I hope you have understood simple arithmetic. Okay. So now suspended solids removed will be 30 minus 15 equals to 15 milligram per liter. Why are we considering that? Because you will see here they are telling not only they are telling not only about the aluminum hydroxide solid, right? So if it was told in the question, calculate the amount of total dry solid sludge on aluminum hydroxide basis, then only you should have calculated this one. But here they are telling that you have to calculate the amount of total dry sludge solid, right? So also the aluminum hydroxide precipitate and also the solid that was removed. How can we calculate? So this is the incoming, this is the outgoing. So the rest one is precipitated. So 30 minus 15 equals to 15 milligram per liter is the solids that was removed. Okay. I hope it is clear from the question. So now the total dry solid that was removed, basically your 5.778 it was milligram per liter plus 15 it was also milligram per liter. So by adding you got 20.778 milligram per liter or gram per meter cube. So this milligram per liter and gram per meter cube, these two units are same. Okay. So if you convert milligram into gram, it will be divided by 1000. So the upper thing became gram and 1000 became 1000 came in the denominator. 1000 liter means 1 meter cube. 1 kiloliter means 1 meter cube. 1000 liter means 1 kiloliter, which means 1 meter. So these two are basically same units, milligram per liter and gram per meter. Now what you can see, the total flow rate is given to 12960 meter cube per day, and you have calculated total solids removed is per meter cube. This amount of solid is removed 20.778 milligram. Sorry, 20.778 gram per meter cube, right? So if you multiply them, then you will get per day how much of what? How much of dry solid is removed? So the total dry solid is removed per day will be 20.778 gram per meter cube into 12960 meter cube per day. That means 269283 gram per day, which is nothing but 269.28 kg per day. Okay. So the answer is not matching. If you have followed the correct procedure, then you should have matched. If there is any mistake, uh, let's say for calculation purpose, then it's okay. If you have followed the correct procedure, then it's okay. But I think you might have missed the 15 milligram per liter, right? You only have calculated based on the 5.786. I hope so. Because if you multiply 114 into 2, it will be 228. And our actual answer is more than that. So let's we assume yes, we are considering only this 5.778. 5.778 into what is there? 5.778 milligram per liter or gram per meter cube into 12960. What is the result? 74882 divided by gram. If it is converted into kg, it will be this one into 2. How did you arrive at this answer? Can you please explain? Because or have you identified wherever you did the mistake? Because if you consider 15 also, then what will happen? Then also
Yes, sir. Calculation mistake.
okay. So you have understood the problem, right? How it is being calculated.
Yes.
Yes. If there
Yes.
is any problem, then you can ask. Otherwise, we move on to our next problem. Okay. So we'll move on to our next problem. So this is the last problem of this session. So a sand filter is to be provided in a water treatment plant that caters to a population of 1.2 lakhs. The average per capita water demand is 140 liters per day and the filtration rate is 16 kiloliter per meter square per hour or meter cube per meter square per hour. Kiloliter means meter cube. If the design basically the filtration rate is filtration flux basically, because whenever you will see liter per hour, that is basically rate, volumetric flow rate per meter square, whenever the rate is divided by the area, then it is called as the flux. So the filtration flux is the more appropriate term. Now if the design allows the filtered water for storage to meet the backwashing requirements and the filter bed is required to expand by 0.4 meter, then you have to calculate the required backwash velocity in meters per second on the basis of the given following sets of data. So the backwash velocity that we will be calculating will be based on Stokes law. So the Stokes law formula for calculating this velocity, the filter's velocity, because this will be the maximum velocity. Beyond this velocity you cannot go. So you have to calculate the Stokes law region. In our next class, we will solve the problem in such a way that the Stokes law will not be mentioned there. So how to solve that problem? It will be a bit complicated one. So we will solve that in our next class. In this class, we will solve only the Stokes law regime. So it will be very simpler for you. So the data is porosity of the unexpanded bed is 0.5. Coefficient of drag is 5.02. Coefficient of drag means CD, C suffix D in the formula. Kinematic viscosity new meter square per second is 1.004 into 10 to the minus 6. Filtered media depth is 1 meter. This nu is what? Kinematic viscosity is dynamic viscosity mu divided by rho, that is the density. That gives you the kinematic viscosity. Filter media depth is 1 meter. Specific gravity of the filter media is 2.5. Okay. And density of water is 1000 kg per meter cube. It is very obvious. And mean particle diameter in millimeter of the filter media is 0.6. Based on that, you have to calculate the backwash velocity. Yes. If you remember the Stokes law formula, then you will be able to calculate. There is also another question. You have to also calculate the head loss based on the above data in meters unit in the filter before backwashing. Yes. So only these two things: the backwash velocity in meters per second within Stokes law regime and head loss in meters in the filter before backwashing. These two you have to calculate. So this is also with the Stokes law regime, whichever is the basic formula, we have to use that one. If you remember the formula, simply you can calculate. You can put the data within the formula and you can get the result. If you don't remember, you can. That's the thing. There is no, I mean, huge concepts involved in this. You just have to remember the formula. That's all. I'll wait for a couple of minutes for you to remember. If you can remember, I'll give you more 5 minutes to calculate. If you don't remember, then tell me. I'll proceed with the solution. This is the last problem of today's session. So you can take the time as much as you can, or you can go back to your materials. If you have taken any note for Sar's lecture, Dr. Velanki's lecture, you can go back to there and you can extract the formula from there to solve the problem also. I'll wait for 5 minutes, 5 to 7 minutes, let's say. Yeah.
So we have to first calculate settling velocity.
What? Backwash velocity will be less than the particle settling velocity. So whatever the formula for particle settling velocity you are having, that will be your backwash velocity only. So that will be the maximum limit for the backwash velocity. Backwash velocity cannot go beyond that. It will be below that. Yeah. Because the dart particle that is deposited within the bed, there is no data. Right. If it was so that the dart particle, their settling velocity and all these things are mentioned, then you could have set the lower limit also. Because if there is the backwash velocity is below the settling velocity of the dart particle, then what will happen? The dart particle will, the filter media will not go away, but the dart particle will also not get removed. There is no data for the dart particle. Right. So you can only the maximum limit you can get. The lower limit you cannot get. Yeah, that's what I can understand from the problem statement.
Sir, please proceed. I am unable to
Okay.
solve it.
Okay. No issues. So the head loss you can calculate in the beginning because head loss formula is bit easier. Okay, I'll choose. So it's just about remembering the formula. There is no huge concept involved. But yes, while deriving the formula, I think I derived the Stokes law formula before. So when I was deriving that formula, then I actually explained that there is some certain concepts are involved. So if you have attended that class, then you will be able, I mean, you will be able to understand. If you have not attended, then I'll suggest you to please go back and see the derivation, how I derived that formula in one of my earlier class. Okay. So now we will solve the problem. So it is nothing. It is just about remembering the formula that was derived. So the specific gravity of the filter media in the question given as 2.5. Now specific gravity means what? Specific gravity means rho s by rho depth. Rho s means what? Rho s is the density of the filter bed media. So the filter bed media has particles. The particle is made of certain materials. The density of that particular material is rho s. divided by rho W. Rho W is nothing but the density of the water. The ratio of the density of that of any solid when compared to the water. So it is basically determining कि वो material पानी से कितना भारी है. So that's why there is the comparison between the two ratios. It is called as the specific gravity. Now density of the filtered media rho s becomes, as the specific gravity is given as 2.5, so rho s becomes 1000 into 2.5. So this rho w comes at the right hand side, which is equals to nothing but 2500 kg per meter cube. Okay. Now this is the formula of the head loss. So it is rho s minus rho w into 1 minus porosity into depth of the filter media divided by rho w. Simple. So you can simplify it like this way. So rho s by rho w, the what? The specific gravity minus 1 into depth into 1 minus porosity. 1 minus porosity means what? So you can see there is a depth. So that means there is a volume, right? And 1 minus porosity. Porosity means the fraction of uh, the fraction of the entire bed that is vacant. That is whether I mean there is no particle. So that is the your porosity. That is your basically the porosity. Okay. So if we are taking the fraction that is not the porosity, 1 minus porosity, that means the fraction of the entire bed volume that is occupied by the particles only. Okay, that is the your fraction of the volume 1 minus porosity that is occupied by the particles, not by vacant places. So only the particles will contribute to the head loss, right? Not the vacant spaces, because water will flow freely through the vacant spaces, the porosity. Whichever area there is not porosity, that means that is occupied, the volume occupied by the particle itself, that portion will be contributing towards the head loss. So that's why we are taking the fraction 1 minus porosity into the depth, because uh, it will be distributed through a depth only. The filter will be more the depth, there will be more head loss. If the filter layer is very thin, then the head loss will be less. If it is more, then there will be more head loss. So depth is a contributor. The 1 minus porosity, this fraction is 1 is a contributor, and the specific gravity minus 1. So water itself has certain weight, right? And the filter media, the SG, that is the specific gravity. This is basically the ratio, a comparison between the two densities. So it has got certain contribution to the head loss. But the porosity that we are considering, 1 minus porosity, this fraction means the portion of the volume which is that is occupied by the solids. So that's why we are subtracting the basically because it is rho s by rho w, that means 2.5 minus 1. So we are subtracting the water specific gravity, that means specific gravity of itself, from the specific gravity of the filter media. That's why we are taking the difference. If you do the derivation, then you will be understand. But in case of heads, head means basically your pressure drop. There will be into G one that is called gravitational acceleration. That term will come into the picture. But if you remember, if you have studied fluid mechanics and if you remember the Bernoulli's equation, then you will see whenever there is one term called as the ZG. This is the height into the gravitational acceleration. If you are converting it into the head term, then the pressure drop term is divided by the G. So delta P by G, that means it becomes in the meters unit. Meter means the head loss. So as the question they have asked it in meters unit, so that's why into G we are not considering that. We are eliminating that, and it is becoming like this way. So Sg minus 1 into 1 minus porosity into depth. Simple. So that means 2.5 minus 1 into 1 minus porosity means 0.5 into the depth. Depth means what? 1 meter. It is given in the question. Yes, depth is given as 1 meter and you have to calculate the head loss in meters. So it becomes something like this. 2.5 minus 1 means 1.5 into 1 minus porosity is given in the question as 0.5, I guess, right? Yeah, 0.5. So 1 minus 0.5 becomes 0.5 into 1 means 0.5. This is 2.5 minus 1 means 1 to 1.5. So 1.5 into 0.5 means half of 1.5 basically. So 1.5 का आधा क्या होता है 0.75. So 0.75 should be the answer. Yes. So head loss is 0.75 meter. Hope it is clear. So to understand the formula, actually you have to see the derivation. That's all. So now the actually it was the second question. It was easier, so that's why it was short earlier. So now it has been asked to calculate the settling velocity within the Stokes law regime. So the formula, I think we have derived this formula. So okay. So if you have not attended the lecture, you can go back and see the derivation. So this maybe for porous media we have not calculated. So there the coefficient of drag, the CD comes into the picture. Otherwise it will be not there. Or 6 pi eta V. Yeah. The single settling it was derived for your settling tank, I guess. Yes. So for filter media, but it is a kind of similar derivation. Only the porosity term will and the coefficient of drag. This term will come into the picture. It is an easy derivation. We will be able to understand. If you see the SATS lectures also, Dr. Velanki's lecture also, then also you'll be able to understand. Okay. So now this is a formula for Stokes law regimes calculation of settling velocities. In the next class, we will see if the Stokes law is not mentioned, then what will happen. That will be seen. That will be seen in our next class. So as in this question, it is mentioned. It is in the Stokes law regime. So we will be using this formula. Vs you have to calculate equals to root 2 under 4 into Sg minus 1 into G into Dg divided by 3 into Cd. So Sg we know it is 2.5. 2.5 minus 1 equals to 1.5. 1.5 into 4, that means 6. So it became as 6. So G is, we know it is 9.81 divided by 3. 6 by 3 means what? 6 by 3 means 2. So 2 into 9.81, it becomes 19.61, right? So 19.61 into dg divided by cd. That is the answer. So what is dg and what is cd? Cd is the coefficient of drag. You can see it is given in the question. So yes, coefficient of drag is given as 5.02. So 19.62 divided by 5.02, whatever is that multiplied by dg. dg is the mean particle diameter of the filter media in millimeters. So this millimeter you have to convert it into meters because this is in sorry yes. So which one you are using in the formula? So yes, this one G 9.81 meter per second. This one you are using in SI unit. So dg also you have to convert it into your SI unit, right? So 0.6 becomes 0.0006 from millimeter to meter. And as I told, 5.02, it is unitless. So 4 into 2.5 minus 1 into 9.8 divided by 3, it becomes 19.62. 19.62 into 0.0006 divided by 5.02, it will come something like this. 0.048 meter per second, which is the settling velocity under the Stokes law. So if it is not mentioned, then you have to calculate it in a general way. That we will see in our next class. So today up to this. So if you have any doubt or you can ask, otherwise we'll end the session here. It is also almost 9. So I'll wait for 1 minute. Thank you. Do you having any question? You can ask. Otherwise, we'll end.
Sir, I have a question regarding backwash velocity.
Okay. Yes. Just Douglas velocity. I told you, no, that it will be the limit. It will be the highest limit. Whatever we have calculated in the question, it is the limit of blackwash velocity, the higher limit. Blackwash velocity cannot go beyond that. It will be less than that.
Sir, is there any use of Reynolds number?
Yes, it will be used. If the Stokes law is not mentioned, then you have to use. You can see in the question there was the mention of mu, right? Share my screen. Where is it? Just right. So yes. So you can see there is one mention of this thing. The kinematic viscosity nu. We know if we are considering the Reynolds number, the formula of Reynolds number is dv rho by mu. That means dv by nu, because mu by rho is nu, right? So dv by nu, the v you have just calculated, the Stokes law, right? So that v you take, then it is particle cellular number. So the diameter, particle diameter you have to take, and that you have to multiply and that divided by this thing, this nu. So then you will get the Reynolds number. Then again you have to check that Reynolds number whether that is falling under the Stokes law regime or not. If it is not falling under the Stokes law regime, then Stokes law regime means the laminar flow regime. It is not falling in that region. Then you have to use the formula which is dedicated for the uh, turbulent or transitional flow, whichever regime is there. So actually we will discuss in the next class. So yes, definitely Reynolds number is used in that, but once the Stokes law regime is mentioned in the question, then you have to just use the formula for Stokes law. You don't have to worry about that. But generally, yes, if it is not mentioned in the question, is a general question, then obviously you have to consider that. We will discuss it in the next class. Yeah. Any more question, or is it clear? Do you have any objection?
Thank you, sir.
Okay. Okay. So thank you. We'll be sharing the recording and also as well as the uh, recording and the PPTs also in the in the dedicated drive, in the dedicated folder we will be sharing. Those who will be attending, those will be watching the recording later, they can access the slides from that, from the folder. Okay. So let's conclude. Goodbye, good night. Uh, we'll join in the 31st March. The 31st March Sunday, that is the last day of the month. Okay. So good night. हाँ बना हो गया